industrial technical training. Today we're going to be talking about the calibration for the early riser planter liquid fertilizer system. In preparation for the calibration, make sure the calibration switch has been plugged into the planter electronics. Also, it's important to make sure orifices have been selected for the liquid fertilizer nozzles and have been installed before the calibration process is completed. The calibration process allows the electronic rate controller to understand how much liquid is actually being dispensed from the fertilizer pump during operation. The rate controller does this by comparing the quantity of electronic pulses coming back from the liquid fertilizer flow meter to the amount of liquid actually dispensed by the system. Access the liquid fertilizer calibration process by entering the work condition menu from the main screen of the display. The tab labeled liquid will contain the calibration process. Once you've entered the liquid calibration tab, it's important that separate work conditions are set up for each of the liquid products that are to be used, and that individual calibrations are performed for each product. For example, if we were running a 1034O liquid fertilizer product, we could set up a calibration labeled 1034O. Once our calibration is performed, the calibration number will be saved to the work condition. Enter the cal value from the tag on the liquid fertilizer flow meter. This will be a starting reference for the rate controller. For example, our flow meter has a cal value of 188 represented in liters. The system will ask you if you'd like to copy this calibration number to all other work conditions. It's recommended that you click no and do not copy it across to other work conditions. The cal value references how many pulses will be fed back to the rate controller from the flow meter turbine, which equals 1 liter of liquid. For example, 188 pulses on our flow meter will equal 1 liter of liquid. The next step in the calibration process identifies if and when previous calibrations were performed. The next step allows you to verify the planter configuration is correct. These values should match the planter as a whole and not necessarily how the planter is being used in the field. For example, our planter is a 1255 24-row 30-inch wide planter. Our planter has 12 rows in section 1 on the left side of the machine and 12 rows in section 2 on the right side of the machine. The next step is to turn on the vacuum and bulk fill fans. It's important to note before this is done that hydraulics need to be engaged and the PTO pump turned on if installed. Once the vacuum fans and bulk fill fan have activated, prime the system, including the seed drive and liquid fertilizer, to make sure that the hydraulics are operational as they would be in the field. The next step is to set the intended liquid application rate and ground speed that will be used in the field. This will also be used during the calibration process to run the system. Verify again that the cal value from the flow meter is correctly entered into the display. For example, we previously entered 188. The next step is to run the calibration process. The display will indicate the target rate per nozzle, which is calculated based on values already entered into the display. Press the Run button to activate the system and prepare it to operate. No liquid will flow at this time until the calibration button is pressed. Press and hold the calibration switch and allow the pump to operate, and allow the system pressure and flow to stabilize. Once these have stabilized, begin collecting samples from several nozzles for 60 seconds. After the 60-second samples have been collected, release the calibration switch to stop the pump system. Press the Run button again to deactivate the system. This will allow you to proceed to the next step, where we can enter the value of liquid that we caught during the calibration process. We need to enter the value captured in gallons per minute per nozzle into the window labeled Actual Flow. In our example, we captured 68.5 ounces from 3 nozzles. We need to divide 68.5 divided by 3, which gives us 22.8 ounces per nozzle per minute. To turn this into gallons per minute per nozzle, we will divide the average 22.8 ounces by 128 ounces to provide us with gallons per minute per nozzle. Our value is 0.178 gallons per minute per nozzle. We'll enter this value into the display and then click the Calibrate button. After pressing the Calibrate button, it will ask if we'd like to copy this cal number to all other work conditions. Again, we recommend saying no. As you can see, the liquid cal value has now changed from 188 to 192. This represents the number of pulses the rate controller is seeing to equal 1 liter of liquid. The adjustment of this cal value fine-tunes the system for the specific product that's flowing through the flow meter. It is recommended that this calibration process be repeated 3 times. This will fine-tune that calibration value even further for the specific product you're working with. Pressing the main button at the bottom of the screen will return you to the start of the liquid fertilizer calibration process so that it can be performed again. After you've completed this process 3 times, the calibration is complete for that specific product. Again, it is important that the calibration process be repeated for each liquid fertilizer product that's going to be used.